people, so what we've got here is a question where we're incorporating algebraic fractions with solving linear equations. How do we do it? Well, we first solve the algebraic fraction. So this is the algebraic fractions over here. We solve that, we get that as one fraction, and then we'll be able to quickly solve it. So you remember how to solve algebraic fractions. All we have to do is multiply the denominators together. So we get 4 times 3. 4 times 3 is 12. And then we multiply that numerator by that denominator. So that'll be 3 bracket 2x plus 3. And we take away from that this numerator multiplied, this denominator multiplied by this numerator. So we're taking away 4x. That's just a revision of what we did last topic. Then we've got 3 1/3. And whenever we have these sort of questions and we've got a mixed number, this is called, we want to convert that to an improper fraction. So we want to go from mixed number to improper fraction. And all that is going is saying, well, if I've got 3 1/3, if I didn't have that whole number there, what's the total number of thirds that I actually have? So to do that, we do 3 times 3 is 9, because there's 9 thirds in 3 wholes. And then we just add that 1 on it. So 3 1/3 is actually 10 over 3. Alrighty. Now what do we do? Well, hopefully you can see in that numerator that you can expand that numerator out. So let's do that. We're going to go 3 times 2x plus 3 times 3. So that's going to give us 6x plus 9, take 4x over 12. And that's going to equal 10 over 3. Then once we've done that, we just want to simplify that numerator as much as possible. So 6x take 4x, they're like terms. We can make that 2x plus 9 over 12 equals 10 over 3. So this is our first step. We've talked about steps before, but we've got a few extra steps we've had to put in this one because we've got the algebraic fraction. So our step 1, all of this step, is actually just simplifying the algebraic fraction. Okay, so that's step 1. Simplify algebraic fractions. And it's a really good idea to actually write down your steps as you're going, because writing down these steps in your example, in your glossary or wherever you're recording your examples, will enable you to go back and have a look at them. So simplify algebraic fractions. Then our second step is going to be to do something called cross multiplication. That's just when we multiply that denominator by that numerator, we multiply that denominator by that numerator. So we can do that magic process of cross multiplication, and we get 3 bracket 2x plus 9 equals 10 times 12, which is 120. Now we get back to a very similar situation that we've had before. Okay, we get back to having a process where we can expand, collect like terms, and then solve for x, which are our steps that we've talked about so far. I'm just going to move this little one up because we got into step 2 there. Here we go. So that's step 1. Step 2 is cross multiply. Now, I know some of you are going, hey, why can you do that? And I'm just going to skip on that and expand and solve this equation, and then I'll come back and explain what actually went on in that step. So step 3 is expand. So if I expand that, I have to expand the number by each of those things in the bracket. So 3 times 2x is 6x, 3 times 9 is 27, so I get 6x plus 27 equals 120. And then I'm going to collect like terms. I don't actually have like terms anymore, because like terms are the things with the same variables and same powers. So I can skip that step, but I'm just going to write it anyway. Collect like terms. We can skip that. And we go straight into solve for x. So what number are we going to get rid of first? Well, we're going to get rid of the 27 first. How do we get rid of plus 27? We take 27 from both sides of the equation. We get 6x equals 93. Equals 93. And then to get rid of that 6, I'm going to divide by 6. So I'm going to get x equals 93 on 6. Hopefully you can see there's a common factor there of 3, so I can simplify that to x equaling 31 on 2. And my equation is solved. Now, let's just go back to that cross multiplication step where I just did something and didn't really tell you what I was doing. If I've got 2x plus 9 over 12, that equals 10 over 3. Well, I want to get x on its own, don't I? Okay, so if I get x on its own, I want to get rid of what's furthest away from x first, which is the 12 in this case. So I'm going to get rid of that divided by 12. How do I do that? I times both sides by 12. So if I times that by 12 and times that by 12, I get 2x plus 9 equals 120 over 3. All right? Now you can go, oh, 120 over 3, well, that's actually 40. Yes, you could do that. Or you could do what? You could multiply both sides by 3. You probably wouldn't, but you could. If you multiplied both sides by 3, if you times that by 3 and times that by 3, you end up getting 3 bracket 2x plus 9 equals 120, which is where we got to here. Okay. Now, in this scenario, it probably wasn't that useful to do our cross multiplication, but if you've ever got a variable up the top there, sometimes it is quite useful to know that it actually works, that you can just cross multiply and then follow the process, and it does work. If you want to do it another way though, that's fine. Alrighty, so hopefully that gives you some idea how you can solve linear equations that involve algebraic fractions.